All right, good morning. Welcome back to Calculus 2. We are looking at our final exam review. You're going to be doing C here. So we have a tank that initially contains 500 liters of pure water, starting from T is equal to 0. Okay. A brine solution with initial concentration of zero point 0.2 kilograms per liter flows into the tank at a rate of 5 liters per minute. A well-mixed solution, because it always has to be well-mixed, flows out at the same rate. So it flows in at 5 milliliters a liter. It's flowing out at 5 milliliters per liter. Okay. And then we have a differential equation governing the system is given below. This is how the problem is going to be pitched to you. So we have pretty much just have to solve this thing. So I'm just going to go ahead and write down the differential equation on the next page so we can just go ahead and start working on this thing. In differential equations, you will be responsible for coming up with this equation. Okay, but for this class, I'm going to give you the equation, so we just have to worry about solving it. Okay, so we have dy by dt is equal to, let's see here, 1 minus y over 100. 1 minus y over 100. Okay, first thing I'm going to do is I'm going to multiply everything by 100 because I'm not particularly fond of the fractions. Okay, so both sides, multiply it by 100. We'll see that that's not the greatest move, but just go ahead and bear with me on this one. So we have 100 dy by dt is equal to 100 minus y. Now, what I'm going to do is I'm going to go ahead and get all the y's on the left side and everything else on the right side. So what we have here is we have a dy over 100 minus y is equal to 1 over 100 dt. Okay? So that's what we're going to do here. Now, we have to integrate both sides here. Okay? Now, we could let u equals 100 minus y. du is equal to negative dy. So that's not going to be too bad. So we actually end up with a negative ln of 100 minus y. I'm going to take off the absolute values in a moment because this has got to be a positive number. Okay? It is equal to, because it's got a application here. 1 over 100 integrating dt, we get t plus c. Okay, I'm going to go ahead and multiply by negative 1. So we have natural log 100 minus y is equal to negative 1 over 100 t. It's still plus a constant. So it's minus a constant or plus a constant. It's still plus a constant. So we're just going to say, well, it's still a constant. A negative constant is the same as a positive constant. They're both constants. We're just going to leave the negative sign in the ether there and not worry about it. And the next thing we're going to do is we're going to solve for y. So what I'm going to do is I'm going to unlogify everything, raise both sides to the power of e. So we get 100 minus y is equal to e to the negative t over 100 plus c in the exponent, okay? So remember that in the exponent, we have e to the a plus b. That's really e to the a times e to the b, right? That's how that works. So that's what we're going to do with that c. So we're going to say we have 100 minus y is equal to c e to the negative t over 100. That's what's going to happen with our constant. This is a step you're going to take more often than you can think in differential equations. So it's one of those things where it's like, what happened to the c? We use the rule of exponents to put it on the baseline rather than keeping it in the exponential. Okay. So what we're going to do now is actually the y and the function is going to change places. So we have 100 minus ce to the negative t over 100 is equal to y. We just trade place. We add y to both sides and subtract ce to the negative t over 100. Now, at t equals 0, how much salt do I have in the tank? So before we start this thing, we have to go back and look at it. Okay. So let's see here. We have tank initially contains 500 liters of pure water. There's no salt. So when we begin with this, we're going to say, okay, here's the salt that's going to happen. Y is the kilograms of salt. Okay, T is going to be, I guess, in minutes, and that's we can go ahead and start with that. Yeah, we have minutes sitting here. Okay, so that's what we have. So Y is the amount of salt, kilograms of salt. This could be anything. Salt's usually the way they do this, but this is used for pollution as well. Okay. So at t equals 0, y is equal to 0. So we have 0 is equal to 100 minus c. I'll put a 0 in here. E to the 0 is 1. Okay. So we're going to be able to say that 100 is equal to c. So as I go ahead and write down my equation, we have y equals 100 minus 100 e to the negative t over 100. Okay, we go back to the problem. We say, oh, okay. What happens when we are looking at the tank after 50 minutes? That was not a number chosen at random. So we're going to say y equals 100 minus 100 e to the negative 50 over 100. That's a half. So we have 100 minus 100 e to the negative 1/2 power. That is equal to y. I have my handy dandy TI-30x2 problem here. So I'm just going to take 100 minus 100 times second function natural log to the negative 0.5. Okay. And we end up with y is equal to 39.35 kilograms of salt. Okay, how do you know how many decimals to go? I didn't. I should have said so, but we're going to use a context clues and kind of say, okay, we have 0.2 kilograms. We have 5 kilograms. At best, we're looking at 1 decimal place. I went 2 just to give you like a little bit extra to kind of deal with, but at best, we're looking at 1, 2 if we want to be generous with the number of significant figures that we're going to be having on this thing. Okay, so that's how you do that kind of a problem. Okay, if you need to use a U substitution, please do so. And like I said, this is like the intro differential equation problem. When you take differential equations, you'll be doing a lot more of these. Okay, thank you very much for watching the video. I'll see you in the next one. Take care until then.